Hi guys, today we are going to solve a very interesting problem from LeetCode. It's a medium problem and the problem statement is binary tree level order traversal. So let me go through the statement and then let's try to explain the problem to all of you. So the problem statement is given the root of a binary tree, written the level order traversal of its node value that is from left to right level by level. So as all we know what is the level order traversal, but those guys who don't know about level order traversal, let me explain. So level order traversal is that we have to traverse the tree from the root by level, and each level we have to print or give the output from left to right. For in this case, in level order 0, there is only one node, so we give 3. Then in level 2, there are two nodes, 9 and 20, so we move left to right, which is 9 and 20. And again from level 2, there are two nodes, 15 and 7, so we move from 15 and then 7. So input is this, and we have to give the output in a matrix, and each row will correspond to each level. So in this case, the first row is 3, then second row is 920, third row is 15 7. Okay, so it's a very standard problem, a very good problem. So how to solve this problem? So as we know, we can do level order traversal on a tree using BFS. What is BFS? It is called breadth first search. So one way to solve this problem is that we will start from root and we will use some data structure which is queue, and we will put this node into a queue and then explore its children. So its children are 9 and 20. Then we will put it into the queue 9 and 20 and we pop 3, and these in the order we push. So this will work from left to right, and we will put, and this is the first level, right? Because 3 is level 0, so we will put into our matrix in another row, and then we will check for children of 9. We will push and we will pop 9 from the queue, and so forth and so on. Okay, so let's try to.
Also, we have to keep track of the levels, right?
Yeah. So that's why I'm popping all the node, and we have to keep trace of the level which we are traversing or which we are exploring. Okay,
Mm.
let's
Yes.
try to solve this problem. So let's say if the root is null, right? If this is the
Okay.
case, then we will return nothing.
Mm.
Okay. Okay. Now we have to return a matrix. So we will make a vector. This is the output, you can say. Also, we require a queue. It is of type tree node, and let's call it nodes that we
Okay.
want to explore. Okay.
Mm.
Now nodes dot push will be the root. So we are pushing our root into the queue, and also we need another pointer. Let's call it front. Also, we need another.
Okay.
We have to track trace basically which level we are exploring. So let's make a 1D vector, and this is called level.
Okay.
So what kind of variable and what kind of data structure are needed, we define. And now let's try to solve this problem. So we will,
Like level, I think, why do we need a vector named level?
we need,
Like for storing all the nodes in a particular level, right?
yeah, that's why we
Okay.
need
Yeah.
level. Okay, so we will try to pop until the queue is empty, right?
Hmm.
While exploring, so we will say node dot empty. Now we will first try to, what is the size of that node, right?
Okay. Yeah.
Now, what is
There
the
is a typo size equals to the line 28. int size equals to nodes dot size in the line 28.
28?
Mm.
Yeah, sorry.
int size equal.
Yeah, which is the size of the queue. Also,
Mm.
we have to, while we are pushing all the node, we have to explore from backward, right? So let's say if I
Uh,
push, let's say if I push 9 and 20, so on the
mm.
top of the queue, this will be 20. But first, while exploring the children of this level, we have to explore 9. So we have to reverse
Because
our,
in case of a queue, we do first come first serve, right?
yeah,
So
yeah, yeah.
we will pick that item, the 9 at
Yeah.
first.
Now let's try to explore.
Like, why are you doing this reverse?
Because in this case, let's say I push the children 9 and 20, right?
Mm.
So what is on the
Mm.
top?
Mm.
20. But when we are doing the
Okay,
BFS
okay.
on the next level, we have
Mm.
to explore the children of 9. But it is on bottom, right? So we have to reverse that.
Okay, like you cannot pop from the front in C++.
No, no, no. So when I, let's
Like
say,
suppose if I do it on Java, then I can like use the queue data structure and I can pull the elements from the front actually.
we
So
are
that's
going
what I
to,
was saying.
so that's also same for C++. For what I'm saying that, so while exploring the children of 3, right? So which
Hmm.
is 9 and 20. So first we push 9 and then 20. So on the top,
Yes.
which node is that? It is 20, right? And
Hmm.
we pop 3 in the beginning. So now we have to explore the children of this level nodes. So what are the nodes in this
Hmm.
level? It is 9 and 20. So but we have to do from left to right, right? So on the top is 20. So but we have to do start from 9. So we cannot access 9 directly, right? So that's why I have to reverse the queue, and that's the reason.
Okay.
I mean the
Yeah,
level.
that's what I was saying. Like in Java, we can just take the element 9 from the front.
Okay, 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 okay.
I got your point.
Okay. So we here we pop the root, right? And now let's
Hmm.
try to push back the value of its children into the vector, right? And if
Hmm.
there's a children
Left.
in the left, then we will also push into the queue.
Hmm.
And if there's a node in the right of the tree, then we will also push into the queue. So because we have to explore these nodes, right?
Hmm.
So I think this is done. Also,
Yeah, we have to put the levels in our output. Yes.
yeah, yeah, yeah. So this is all the nodes in the given level, and I'm just pushing into my vector of vector, which is the
Hmm.
matrix, right? And also
Yes.
I have to remove all the elements in that level now, because I have to explore
Okay.
the another level,
Hmm.
and this will do all the job. So what? Let me go uh, do through the code. So it will
Okay.
first push 3, then queue is not empty, then this will
Hmm.
define all these things. It will reverse, then it will push its children here into the queue and also into the level, right? Because
Okay.
I have to.
Okay. Hmm. Hmm. Hmm.
So
Yes.
this will push 9 and 20 into the level, and also into the queue because I have to now explore its children's level.
Their children. Yes. Yes.
When it is done, then I will push my level into the vector, and then we will clear the level because now there's no need to 3 because we explore 3. Then this will do for 9 and this will do for 20. So there's no children of 9, so this will do nothing here because here we are checking, right? And for 20 this will do, and that will do the job while all the nodes are explored because there is the empty condition. In the end, I will simply return my vector of vector, all the level. Let's try to.
In the line 41 semicolon.
Let me try. Let me explore through the code because this time I want to make it work. Yeah, it's
Okay,
okay.
got accepted.